Hi guys, in this video I'm going through this question from May 2016 and it's on circular measure. So I suggest that you pause the video and you try it out yourself. Then you play it to compare your answer and working with mine. And with that being said, let's dive right in. The question is saying the diagram shows triangle ABC where AB is 5 centimeters, AC 4 centimeters and BC 3 centimeters. Three circles with centers at A, B and C have radii 3 centimeters, 2 centimeters and 1 centimeter respectively. The circles touch each other at points E, F and G lying on AB, AC and BC respectively. Find the area of the shaded region EFG. Right? So we're going to find the area of the shaded region D. Right? And usually, for us to get the area of a shaded region, we would say area of the whole shape, meaning this whole triangle, subtracting area of the unshaded parts, which are this part, and this part. And just by looking at this, you can see that these unshaded regions are sectors, right, of different circles, right? And for us to get area of sectors, we need the radius of each of the circles, which we are given in the equation, but we're not given the angles, right? Because we would want to use half r squared theta for the area of each of these sectors. So we need this angle, this one, and this one, right, for us to get those areas. And with one of those angles, we can also get the area of the triangle, this, right, by using half AB sine theta. So in other words, we're going to use this to get the area of the triangle. Then we use this to get the areas of these unshaded regions, which are sectors. Then we're going to add the areas of these sectors. Then we subtract them from the area of the triangle. Right? And so for us to start our calculations, we need any one of these angles. And as you can see, we have a triangle ABC with all sides given and none of the angles given. So we can use the cosine rule there, which states, for example, let's say we want to get angle at A. Let's just call it A. We would be saying A squared equal to B squared plus C squared minus 2BC cos A, right? And we get these lowercase letters from naming our triangle, like the sides. So if this is a capital letter A, we can name the opposite side small letter a. And if this is our B, we can name this side our small letter b. And if we have C here, we can name this side C, like that, right? And with those, we will substitute them in here. So what we want is the angle. So try and make cos A the subject, and in doing that we have cos A being equal to A squared minus B squared minus C squared over minus 2BC, right? And to get A, we're just saying the cos inverse of this. So it's cos inverse of A squared minus B squared minus C squared all over minus 2BC, like this. So now we're just left with substituting the values. So our angle at A is the cos inverse of A, this, which is 2 plus 1, that's 3, so 3 squared, minus B is 3 plus 1, which is 4 squared, minus C is 3 plus 2, 5 squared over minus 2, or b is 4, and our c is 5, like this. And if we punch this in our calculators, we get our angle at A to be 0.643 radians, right? We get it to be 0.643 radians, like that. So now with this angle, we can get these other angles by using the sine rule. Remember, the sine rule is like, if we have a side, right, A over the corresponding angle at A. So let me put it this way. If we have a side A over its corresponding angle, it's equal to the other side over its corresponding angle, is also equal to the third side of the non-right angle triangle over the corresponding side, right? So now we have angle at A, meaning we have this ratio right here, right? So for that, we will be saying our side A, which is this 1 plus 2, that's 3 over sine A, that's sine 0.643, is equal to our B over sine, let's just substitute the B. Our B is 3 plus 1, 3 plus 1, that's 4, 4 over sine B, right? Making sine B the subject, it's sine B equal to 4 sine 0.643 over 3. So B will be the sine inverse of this. Over 3, right? And this will give us B to be sine 0.46 over 3. So B is 0.927 radians, right? And with these two angles, we know angles in a triangle add up to what? 180. And 180 in radians is pi, right? So we're going to subtract these two angles from pi to get the last angle at C, right? Let me just rub this. So it's pi minus 0.643 minus 0.927. Then we get our angle at C to be 0.927. It's 1.57 radians, like this. Now with these angles, we are just going to get the A of the triangle first, right? Remember, we said we were saying half AB sine theta, right? We pick whichever angle we want to use, but for this case I'm going with my A to be this and my B to be this, right? So it's half, my A is 4 and my B is 5, then sine the angle in between the two sides, which is this 0.643, right? And the area of the triangle will come down to be 10 sine, it's 5.995, which will give us 6 after rounding off, right? And the areas of the sectors, starting with this one, so this is our 2, then our 3. So area of sector 1, that's half r squared theta, which is half. R of that circle is 3, the radius, so that's 3 squared. Then the theta angle at A is 0.643, right? Then for sector number 2, we're saying half R squared. R is 4, so that's R is 2, then 2 squared is 4, so it's half 4. Then theta angle at B, that's 0.927, right? Then sector 3, we're saying half 1 squared, which is obviously 1, times the angle at C, 1.57, right? And if we punch these three in our calculators and add them, we should get half 1.57. We should get 5.3. Oops, it's not 5.3, it's 5.532, like this. So we're simply going to say the 6 minus 5.532, right? And this will give us the area of the shaded, which is 0.464. So our dimensions are in centimeters, so this should be square centimeters, like this. Right, I hope that was clear.